Electrostatics. Suppose the charge of a proton and an electron differ slightly. One of them is minus E, the other is E plus delta E. If the net of electrostatic force and gravitational force between two hydrogen atoms placed at distance d much greater than atomic size apart is zero, then delta E is of the order of. So here, first of all, let's calculate net charge. So minus E plus delta E will give delta E. Now we have to find out the force between two delta E. So here delta E, and the separation is D. So electrostatic force Fe will be equal to delta E square divided by 4 pi epsilon naught into T square. Now gravitational force. So Fg is equal to capital G into m1 m2 divided by d square, 6.67 into 10 to the power minus 11 into mass of hydrogen atom, that is 1.67 into 10 to the power minus 27 whole square divided by d square. Now this will give delta E square divided by into 9 into 10 power 9 due to 1 upon 4 epsilon divided by d square. It is given that net force is 0, that is Fg must be equal to Fe. So from here 6.67 into 10 to the power minus 11 into 1.67 whole square into 10 to the power minus 54 divided by d square will be equal to delta E square into 9 into 10 power 9 divided by d square. So from here we can get delta E square. So delta E square equal to 6.67 into 10 to the power minus 11 into 1.67 square multiplied by 10 power minus 54 divided by 9 into 10 to the power 9, which will come out to be 2.067 into 10 to the power minus 74. So delta E will be the square root of this. So we will get delta E equal to square root of 2.067 is roughly equal to 1.437 into 10 to the power minus 37 coulomb. So this is our answer. Now let's consider second question. Second question is, two pith balls carrying equal charges are suspended from a common point by strings of equal length. The equilibrium separation between them is R. Now the strings are rigidly clamped at half the height. The equilibrium separation between the two balls now becomes. So situation is like this. Here charge is Q, here charge is Q, and this line is suppose this length is equal to R. Now this perpendicular distance will be y. Here mg will act downward and force of repulsion will act in this direction F. Now we can apply Lamin's theorem. So force divided by side proportional to it. Force divided by side parallel to it or in the direction of it is constant. So here, if we consider this triangle OAB. So in triangle OAB, force F, then we have to consider side AB. So we can say F divided by AB equals, when we consider mg, then side parallel to it or in the direction of it will be OA. So mg divided by OA. So force of repulsion between these two charges will be equal to q square divided by 4 pi epsilon naught r square divided by AB. AB will be equal to, this total distance is r, then AB will be r by 2. So here we write r and we shift to here. So we have got F upon AB equal to mg upon OA. So OA is y. Suppose this is equation number 1. Now consider second situation when the string is clamped halfway. So we can say that string is clamped here. So now two charges are here, one charge is here, another charge is here. Now this time suppose separation is x, so this height will be, if this is y by 2, this will also be y by 2. So now suppose this is a dash, this point is b dash, this point is c dash. Now here we are taking c dash. So in downward direction there will be mg, and in this direction there will be force F. This time suppose we take this force F1. So same rule we can apply, force divided by side parallel to it or in its direction is constant. So we write F1. So F1 upon CB dash, F1 upon CB dash equal to mg upon AB dash, mg upon A dash B dash. So this time F1 is force of repulsion. So that is equal to q square divided by 4 pi epsilon naught, and then separation is x square times A dash. This time we have to write CB dash. So this point is CB dash. This distance, this will be x by 2. So we write x here and 2 here equal to mg will remain mg divided by A dash b. So this will be y by 2. So this 2 will also set in numerator. So this 2 will and this 2 will cancel out. So this time we have got q square divided by 4 pi epsilon naught x cube equal to mg upon y. This is second equation. Now first equation says 2q square divided by 4 pi epsilon naught r cube equal to mg1y, and here this is q square divided by 4 pi epsilon naught x cube. So the two equations will be equal. So from where we get 2q square divided by 4 pi epsilon naught r cube equal to q square divided by 4 pi epsilon naught x cube. From where we get 2x cube equal to r cube, or x equal to, first we write x cube equal to r cube divided by 2, from where we get x equal to r divided by third root 2, which is our answer. Now let's consider next question. Two positive ions each carrying charge q are separated by a distance d. If F is the force of repulsion between the ions, then the number of electrons missing from each ion will be. Let's consider the solution. So here F equal to Q square divided by 4 pi epsilon naught, separation is D, so D square. Now we write Q square equals F times 4 pi epsilon naught T square, but Q equal to NE, quantization of charge. So we write here N square E square equal to F times 4 pi epsilon naught D square. Our purpose is to get N. So N square equal to F times 4 pi epsilon naught D square divided by E square, or N equal to square root of F times 4 pi epsilon naught D square divided by E, where E is electronic charge. Now let's consider next question. A pendulum bob of mass 30.7 into 10 power minus 6 kg and carrying a charge 2 into 10 power minus 8 coulomb is at rest in a horizontal uniform electric field of 20,000 volt per meter. The tension in the thread of the pendulum is. So situation is like this. Uniform electric field is directed like this. So downward there will be mg, and in this direction if charge is q and field direction is electric field G, then QE force will act in this direction. This angle will be 90 degree. So tension will be equal to net force. So tension will be equal to square root of QE square plus mg square. Now we evaluate separately QE. So QE charge is here 2 into 10 to the power minus 8 times electric field 20,000. That will give 4 into 10 to the power minus 4 Newton. Similarly, mg will be equal to mass. Here mass is given as 30.7 into 10 to the power minus 6 into g is say 9.8. So which will give around 3 into 10 power minus 4. Now net force will be equal to tension, which is equal, it will be 4 square plus 3 square multiplied by 10 to the power minus 4, which is equal to 5 into 10 to the power minus 4 Newton. Now, let's consider next question. 3-point charges Q minus 2Q and plus Q are placed at x equal to 0, y equal to a, z equal to 0, x equal to 0, y equal to 0, z equal to 0, and x equal to a, y equal to 0, and z equal to 0 respectively. The magnitude and direction of the electric dipole moment vector of this charge assembly. So here we draw 3 axes. Minus 2q charge is at 0, 0, 0, and plus q charge is at a 0, 0, and another charge is here at 0, a 0. This is also plus q charge. So there are two dipoles. One is here in this direction. We separate these two charges here. Minus 2q charge can be written as minus q and this plus q for first. Similarly, minus q and plus q for second. So two dipoles are there, and the angle between them is 90 degree. Direction of dipole will be from minus to plus charge. So dipole moment of each dipole will be separation times charge. So separation is A times charge is Q. So net dipole moment P net will be equal to square root of AQ square plus AQ square, that is AQ times root 2, and its direction will be like this. So the corresponding points will, here corresponding point will be A comma 0. This is x-axis, this is y-axis, and this is z-axis. So this is our answer. Let's consider next question. A charge Q is placed at the center of line joining two exactly equal positive charges. Suppose this is capital Q charge, this is also capital Q charge. Here, small q charge is placed. This distance is equal. So suppose this distance is x, this distance will also be x. Now we have to find out what is the relation between capital Q and a small q. So we consider net force on this. Since system is in equilibrium, then we can say that net force on the charge at point A will be 0. So it is only possible when small q is negative. So we can say QQ divided by 4 pi epsilon naught x square plus, if q is negative, then in this direction there will be force of attraction between small q and capital Q, and due to this q charge at C and this q charge at A, there will be repulsion which will be in this direction. Their sum must be 0. Only then system will be in equilibrium. So we can say QQ divided by 4 pi epsilon naught, and distance will be 2x whole square must be equal to 0. So from here, we can cancel capital Q, 4 pi epsilon naught, 4 pi epsilon naught. So we are left with Q upon x square plus capital Q upon 4x square equal to 0. Again, we can cancel x square. So from here, we get small q equal to minus capital Q upon 4. This is our answer. Thank you for watching.